Okay, so I'm going to look at a polyprotic acid, and my polyprotic acid is the sulfuric acid. And if I look at the problems that you have for homework, this is like numbers 93, 95, and also number 97. Okay, so what we have is a solution of sulfuric acid, and we're trying to find the concentrations of all these different ions. And I forgot to tell you the molarity. Let's just do 1 molar. Okay, so in a 1 molar solution. So we have our first dissociation, and we know the Ka is very big, so we just pretend like it's 100% dissociation. Okay, and that's a safe assumption to always make, so we're not too worried about that. And what we do is, if it's 1 molar, that means that after this dissociation, we have 1 molar solution of H plus and 1 molar HSO4 1 minus. So the Ka is very big, so we're not worried about the H plus contribution from this species. So we know that the H2SO4 is going to be 0 because we're pretending like it's all gone. And the H plus is not going to change either. It's going to be 1 molar. So we now need to find the concentrations of these two, and we can do that using ice and a Ka. We have HSO4 1 minus dissociates to H plus plus SO4 2 minus. And initially we have 1 molar, and initially we have 1 molar here, and initially we have none of this. So we lose X, we gain X, we gain X, and we get X minus 1 minus X, 1 plus X, and X. We're going to neglect the X. Now, we know the Ka because it was given to us in the problem, and the Ka is equal to 1 molar times X times 1. No, very nice. It just goes away. So X, my SO4 2 minus is equal to the Ka, which is 1.2 times 10 to the negative second. Okay. And if we check that number is that would correspond to 1.2%, which is less than 5% of 1. So it's safe to make that assumption. So that means that the concentration of the HSO4 1 minus is 1.0 molar also, and the SO4 2 minus is 1.2 times 10 to the negative second molar.